right. Hello, everybody. My name is Josh. I'm a senior solutions architect with SMS Data Products, and I'm going to talk about securing secrets in Amazon ECS. This is a beginner level talk, but I expect that you know what ECS is, you know what an ECS task is, you know what a container is, and you understand some of the basics of that. I work on a small commercial team at a larger company, and I get to work with clients of various levels of maturity in AWS. So I do see some things that are not best practice, that are, kind of naive implementations of things. And I also get to work with larger companies in regulated industries and see some of the best practices and separations of concerns across teams. So today, I'm going to cover some anti-patterns and then two actually good patterns to share secrets with your containers. All right, your containers are going to need secrets, most likely. Those can be API keys to external services, database credentials, encryption keys, lots of other things. How you get those secrets to your containers can matter. It affects where the secret is exposed, who all can access the secret, how do you rotate the secret, right? And other operational concerns. All right, we're going to start by going over an example application and deployment pipeline. Very simple, just to have some shared context as we talk through these patterns. Then I'll go over two anti-patterns, certainly ways that most people are not sharing secrets with containers, but some people are. Then I'll look at two patterns that are recommended and the trade-offs between them, because there's not always a clear, do this every time solution. All right, let's look at our example application. We'll just say it's an API, doesn't really matter what it is. But we have a containerized application running as an ECS task. We're going to use Fargate for compute. This is part of an ECS service, and it's fronted by a load balancer. Now our API, so this ECS task, it needs to access an external email provider. So there's an API key that would be secret. We're also utilizing Postgres on RDS. So we potentially have database credentials, though there are some other solutions to make those temporary. All right, let's talk about two different pipelines. One is the application deployment pipeline. So in this scenario, our code is stored in a Git repository. That Git repository is hosted on GitHub. And we are using GitHub Actions workflows to build a container image and push that container image to our container registry in AWS, which is ECR. We're also using that pipeline to deploy the updated application to ECS. There's a few different ways to handle that last deployment part, but it's not really relevant for this discussion. All right, our second pipeline would be the infrastructure pipeline. In this scenario, we're using Terraform. We're storing the Terraform code in a Git repository in GitHub, and we're using the GitHub Actions workflows again to run a plan and preview the changes from our infrastructure changes, and then actually apply them. Now, when you use a tool like Terraform, there's a mapping between the code that you wrote that represents the infrastructure you want and the actual deployed infrastructure, right? A thing to connect those pieces. That's called your state file. So our state file in this case is stored in an S3 bucket in our AWS account. All right, throughout this discussion, I want you to think about when are secrets set and when are they read? There's really three time periods that I'm going to hit on. One is during the container build or infrastructure deployment, right? You could set secrets at that time period. Another is at container launch. When you spin up your application, actually launch another instance of it, are you reading secrets then? And then finally, at application runtime, without restarting or launching your application, can you read secrets? All right, the first anti-pattern is secrets directly in container images. Right above the diagram, I have an excerpt from a Docker file. Kind of two things are going on here. One, I'm setting an environment variable called db_password. I'm just setting it to a string literal, right? My secret password. That is very bad. I don't know if everyone's worked a lot with Docker containers, but when you build a container, you are baking this string literal directly into that container artifact. So anywhere that container artifact goes, a developer's laptop, the registry, a different runtime environment, that secret will always be there. The second line is a copy command. I'm copying a config with secrets JSON into my container artifact. Same exact problem. I'm baking that secret into my container, and it will be there anywhere the container goes. One caveat to this, one thing that I see a lot of times, since we're hosting in GitHub, I'll often see the Docker file referencing a GitHub secret, right? Instead of my secret password, we'll see something that reads from the GitHub repository secrets and replaces it. That's kind of the same thing, right? You're still building that secret into the container image, and you're still sharing it in a lot of places. All right, so if you use this method, where all is your secret exposed? Well, first, in your Git repository, right? Anyone with access to the source code. You've got a third-party developer who comes in for a few weeks, they have your credentials. In your build logs, potentially. There's a lot of ways to mitigate that, but it's best to just remove it completely, because these could end up in your CI logs and a lot of other logs. And lastly, in your container registry. Anyone who has permissions to pull that container image will have access to that secret. All right, what does secret rotation look like if this is how you're managing your secrets? Pretty much a full deployment of your application. You would update the secret value, whether that's in your GitHub repository secrets or that's directly in your source code, rebuild the container image, push it to your container registry, update your ECS task definition or however you are deploying the task, and redeploy all of the services. So somewhat involved secret rotation. All right, if you don't think this is happening, if you're thinking like, oh, no one's actually doing this, when 2024, there was a scan of 15 million public Docker Hub images, over 100,000 valid, so not even ephemeral temporary credentials that were invalid, but 100,000 valid secrets for AWS, GCP, GitHub tokens, and some of those from Fortune 500 companies. So this is very much happening. And again, the most common thing I see where people think they're safe, but they're not, that's storing the secret in their GitHub organization or repository secrets and then referencing it in the Docker file. Because again, that build is reading it and baking it into the image. All right, anti-pattern number 2. This is putting the secret directly in your task definition. So a task definition is a JSON document that describes a lot of attributes from your ECS task. Well, one of those attributes is environment. It's an array of basically key value pairs, so the name of the environment variable and the value. I often see teams putting secrets directly in this. They could still do the GitHub secrets method where they kind of inject it in here, but you've got a similar problem. Your secret is exposed in the source code in the GitHub repository. If you're managing your task definition as part of your application code, then it's exposed all the places of the previous diagram. If you're managing your task definition as infrastructure, if you're treating that with your IAC, maybe it's in Terraform, then you've got your IAC repo that has the secret, you've got your Terraform logs, and your Terraform state, which I'll caveat, pretty common to have sensitive values in the Terraform state, so that's not as big of an issue. But one kind of additional issue for more mature teams, well, now your secret is available to anyone who can read that ECS task definition, right? Some teams have access to everything. At smaller organizations, the developers are the ones in AWS, they have the root credentials, they can do everything, and this maybe doesn't feel like it matters. For a lot of other teams, there's a separation of concerns here. These secrets should not be accessible to the same teams who may view or modify the task definition, whether you treat that as part of the application or part of the infrastructure. All right, so what if our secrets just never appear during build or infrastructure deploy? We can avoid an entire suite of potential issues. So now we're going to look at 2 recommended options for managing the secrets. One is focused around the container launch, and when we launch that container, reading the secret. The other is at application runtime. Before we jump into that, there's 2 IAM roles that I want to make sure we're clear on because they're easy to mix up. So when you're working with ECS, you have a task execution IAM role and you have a task role. The task execution IAM role is used by the ECS service, right? By AWS ECS as a service. That defines the permissions needed for AWS to pull your container image, potentially read some secret values, as we'll get into, and create logs from your container. The task role, that is used by your application for whatever your application needs. Let's say in this example application, it's an API that needs to read and write to S3. My task role would have IAM permissions that allow me to read and write from S3, and those are available at runtime to my application. All right, first recommended pattern, ECS native secrets injection. So that's kind of my term here to collect a few different things. You won't find that necessarily in the AWS documentation, but I'll show an example of what it looks like. So here you are deploying a task definition file, but in that task definition file, you're not putting the secrets. You're putting a reference to the secrets, which I'll show you in the next slide. So ECS is using that task execution role to use permissions to read the secret and inject that secret into the runtime environment for your application. So the big difference here is that ECS task definition file doesn't just have the string literal of your secret. It has a reference to a location that the secret can be retrieved from. The end result is that your application will start and that secret will be available as an environment variable. So here's what that looks like. I've got another excerpt from the task definition file, and I'm looking at the attributes secrets instead of environment. Also, key value pairs, you can see the name of the environment variable, in this case, db_password. And now instead of value, I have a value from property. The value from property contains an ARN of the actual secret. You can see in the top example, this works with Secrets Manager, and in the lower example, it also works with parameter store. So you can do either one of those things. And again, the task execution role will need permission to read these resources. One other note here, you can also mount secrets in S3, right? You can have a secret in an S3 bucket and expose that as an environment variable inside of your ECS task. It's very similar to this. It predates this functionality. I don't see it very often, but you may come across it. All right, so what does this ECS native secrets injection solve? Well, no more secrets in your source code, whether that's IAC, task definition, or your actual application Docker file. No secrets in your Terraform state, and no secrets in the AWS console or API responses related to ECS. So those teams of developers who shouldn't see the secrets, but they need to see the task definition, you have that separation. No secrets in your CI/CD logs from building containers and deploying the applications. And you can use IAM to scope the access controls. Who can read from Secrets Manager? That is typically tightly controlled, whereas who can interact with ECS is usually less controlled. And of course, you gain CloudTrail audit logging with those solutions. All right, what does it not solve though? Well, this is very popular right now, but supply chain exploits. If you have a malicious package like Axios, I'm sure some of you guys have heard about that recently, well, if those end up in your application, they can read environment variables. And this process ultimately exposed these secrets to your app via environment variables. So some other process that can read environment variables can read these secrets. Also, debug endpoints. Very common for frameworks to have some kind of local development debug mode, right? And it's very useful for local development, but if that's somehow enabled in a production build, an unhandled exception or some other thing can trigger a dumping of environment variables, right? And this would not protect your secrets because they exist as environment variables. And finally, application logs. Of course, your developers can always unintentionally log environment variables and thus expose your secrets. All right, what does rotating a secret look like in this manner? Well, you update the secret value in Secrets Manager or Parameter Store, wherever you're keeping it. Then you force a new deployment. A few different ways to do this. But the key here is that you don't have to rebuild your application and redeploy the whole thing. That may not matter a lot for smaller applications, but for larger ones, that can be significant. Now, when you do redeploy this application, new tasks that are launched will have the new value, and the tasks that were previously executing will still have the old value. So this very much is a rotation where you create a new valid credential while your old one is still valid, and then replace all of your running instances. Then you can invalidate the old credential. All right, let's look at the final recommended method, which I'm calling application level secrets retrieval. In this case, we are fetching the secrets in our application, right, at runtime. We're not doing it when the application starts and then never retrieving them again. Usually, you will use the AWS SDK to read directly from Secrets Manager or Parameter Store. The SDK running in this ECS task is going to use that task role that we talked about earlier. So in that task role, you define my application can read from this secret. And now the SDK, via what's called the credential provider chain, it knows how to find temporary credentials to read the secret that you want. All right, here's an example of some TypeScript code that reads a secret from Secrets Manager. I'm not going to go through this. I don't think it's important. I just added it in the slide to show you that this is a trade-off. You're adding complexity. With all of the other methods, including the ones that are not recommended, your application's reading from environment variables, which is what most of them do, right? Most of the time in local development, developers have hopefully not, but a .env file or other methods that expose secrets and configuration as environment variables. So the first three methods aren't really a change. But this one is very much a change to your application code. All right, some more trade-offs to consider with the application level retrieval. One is Secrets Manager isn't free. You do pay per secret that you have stored, but you also pay for API cost. At a small scale, this probably doesn't matter. At a larger scale, it very much can matter, and it can be expensive. Another thing is rate limits. Like, it'd be very unfortunate if you don't meet your availability goals because you're rate limited trying to be secure, right? So there are trade-offs to consider with rate limits to the Secrets Manager API. And with those rate limits and additional cost, you often implement caching. You don't need to read that secret every single time that you need to use it. So typically, teams will implement caching when using this at scale. With caching and the application level changes, well, you've just introduced some complexity, right? Not only does your team need to understand how to do this, but they potentially need to test it, it needs to be vetted, and it may need to be modified one day. Also, startup impact. Some containerized applications running in ECS, startup doesn't matter, right? It really doesn't matter. But for other ones, they're measuring it in the tens of milliseconds, right? They really care. And anytime you add a synchronous API call to the startup of something, you're adding tens, maybe 100 milliseconds to it. So if startup really, really matters, the speed that your ECS container starts, then you may not want to add this synchronous fetch in front of it. And lastly, you would implement this for every service. If you have a lot of different ECS tasks and you're trying to do this, you're going to do it over and over again. I will say, caveat to that last one, usually people build abstraction layers around this, right? If a lot of your services are written in TypeScript or Python, teams will often create a package that handles the caching and the fetching, and they'll just reuse that package. A lot of times in a mono repo that all their services are in, they'll have a shared package and consume it from each service. There are also open source options that you can build on top of that handle the caching and the fetching. They can run as a sidecar container in ECS, so a second container that your application will then fetch secrets from, and that other container will handle the caching and the actual fetching. Okay, kind of wrapping up here and comparing the approaches. So my vertical columns are the 4 different methods. My rows are where are your secrets potentially exposed. So when you bake them in the image, so that is that Docker file having the string literal, you are exposing your secret in your source code. You are exposing it in the container registry, which means anybody who can pull that image has access to that secret. of course, the environment variables in your runtime, and by necessity, the application memory that's actually running. So if you are sharing your secrets via the task definition, so the second column, well, you're exposing it in source code. That could be your IEC code if you store task definitions there. That could be your application source code if they're stored with the application code. Also exposing it in Terraform state and environment variables application memory as well. All right, now on to the two recommended methods. The first and most simple ECS native injection. So you are only exposing it as an environment variable in your runtime, which isn't necessarily a bad thing. And then of course, application memory. And finally, app level retrieval that we just went over, only expose application memory and you control that. All right, rotation approaches. When it's baked into the image, you need to do a full deploy. You need to update your code, you need to build, you need to push to ECR, and you need to deploy. When you put that secret in the task definition, you may need to deploy an infrastructure change if that's how you track your task definitions, or you may need to deploy the application change, but it's a similar story. With ECS secrets injection, you just need to update where that secret is stored, parameter store, secrets manager, and then relaunch your task. New task will have the new value, old task will have the old value. And then with app level retrieval, you just update the task. Of course, hidden complexity here, your caching, right? How long is that cache valid? How do you actually make your application retrieve the latest value? All right, wrapping up with practical recommendations. So regardless of what you are doing right now, you should understand where your secrets are exposed. From the place that you store them to the place they are consumed, that whole journey, where all are they exposed and who potentially has access to them. You should document your secret rotation procedures. I think we're going to see more and more supply chain attacks. Like I feel like it's happening right now. And a very common thing with these supply chain attacks is just reading all the environment variables and exfiltrating them, right? And those environment variables often are where your secrets are. So you should know how to rotate your secrets. You shouldn't be figuring it out as you go. You should remove secrets from your container images. They shouldn't exist there. It's happening. That stat I showed earlier, over 100,000 active credentials in publicly available containers. And then lastly, if you're utilizing secrets managers at scale, you should handle caching. Your bill will thank you. All right, that's all I have. Thank you. Again, my name is Josh Grant. If you guys have any questions, I think I am out of time, but I'll take them on the side. Thank you.